Hey guys, welcome to Coronavirus Earth Science Day 8, which today we start something new, correlation. All right, don't forget you got your CASA learning and your lab due on Saturday. Those are your 2 grades for this week. Make sure that you get it done. All right, by this point, you should have had your lab done. Okay, you had Monday and Tuesday to get it done. So hopefully you got it done. So how can we correlate rock layers? So if we're talking about rock layers, correlation means basically just matching them up, okay? So let's just get through these do now questions. Draw a circle around the letter of the oldest rock, all right, oldest rock unit shown in the cross section. So remember, oldest means that it came first, okay? The oldest kid in your family is the kid that was born first. So if you look at this entire thing, I would say that the oldest thing, the thing that happened first, was I, all right? And my reasoning would be that it's probably the one all the way on the bottom. Even though it was tilted eventually, it is on the bottom. And I knew it was there before this sandstone or H or this sandstone because there is no contact metamorphism here, right? It's not burning them. So that means that it was there and it cooled and then the sandstone came on top. Okay, next 31. On the cross section shown, place an X to indicate the location of where the rock marble was formed. All right, so we have answered questions like this in the past. You should remember that marble, or if you look it up, marble is a metamorphic rock. All right, and metamorphic rocks have to be located on the contact metamorphism dash lines. Okay, so, and if you look up marble, marble comes from limestone. So you're going to look for all the locations where a limestone is touching the contact metamorphism. So you could have put your answer here, 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 here. Any of those would have been fine. Basically, anywhere where there is contact between the limestone and that magma, okay? Anything on that would have been acceptable. Okay, moving on. So, arrange the outcrops from old to young as one rock column. Now, the fossils that you see here, these are index fossils. And if you remember correctly, index fossils are short-lived and widespread, meaning that they covered a great expansive piece of geographical area and they were only existed for a short amount of time. Now, if it says this fossil is 10 million years old, that's older than the other one. So this one should be on the bottom, all right? And then these should be closer to the top. And then you should just match them up. If you see that these two are the same, then that means that you can basically overlay them. And if you see that these are the same, then you can basically overlay them. Okay, so I'll show you what I mean right now. Take a look. Okay, see, they're basically the same thing. If those have the same index fossils, then you know that they existed at the same time period. And then it just so happened that the limestone matched up. Okay, and now match these guys up. Okay, and then now you have your story. So this can actually go in your do now worksheet, right? You had two questions for a do now that are different from the ones that we just did. And then you had the geologic rock column activity. That's this. So in that you would write that this is siltstone, that this is breccia, right? that this is shale, and it has this fossil in it, which is the 10 million year old one. You had your limestone, you had your sandstone, and then you had this fossil, which is 3 million years ago, and then you had your conglomerate. All right, there is a lab that we would have to do this, but it involves cutting and pasting and stuff, so I don't think we're going to be able to do it this year. All right, moving forward. So, correlation, like I just said, you're matching fossils, layers, you're matching rock layers to get basically this big picture, this big story. Okay, matching rocks or events occurring at different locations, all right? Different locations, but at the same time, all right? And this, again, is where we have evidence of Pangea, right? Which you can see here. We know that these were all once connected, not only because they fit together like a puzzle, but also because their rock record and their fossil records might match up. And that's kind of similar to what we just looked at here and here. Okay. We just said that. Okay, how do we correlate rock layers? By correlating, which means matching, rock texture and composition. So fossils and what types of rocks they were. Okay, fine. Index fossils, remember, widespread, short amount of time. So they are excellent time markers. If you find that fossil, you have a precise time period that you're looking at. So here's another example of trying to find out which is the best index fossil. So here you have 4 different places, and they all have fossils in them. Which one would be the best index fossil? Is it going to be A, B, C, or D? Remember, widespread. So whichever one it is, it should be in all 4. And short-lived. That means that it should only be in one layer. It shouldn't be expanding all throughout time from top to bottom. And if you looked very carefully, you should have chosen B. Because B is in here, 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 and here. It's on all 4, and it only existed for a short amount of time. Look at A. A is all over the place, right? Look at C. C is the trilobites, all over the place, right? It existed for a long time. And D is not good because it only was in Africa. Okay, so B should be your answer. All right, other time markers that we could use would be ash and meteorite deposits. All right, anytime a volcano erupts, it's going to deposit this huge layer of ash, and it's going to be very widespread, and it happens for a short amount of time. It's an excellent time marker. And same thing with meteorite deposits. This is actually how we have an exact time period as to when the dinosaurs died. There's a layer of iridium that goes around the world at that precise time, and that came from the asteroid that came and hit Earth. So here would be another example, right? You can see that nice clear layer that's going to run across. Okay, so we know that this is page 8 and 9. We know that we are just talking about our index fossils, right? Okay. And we know our time periods and all that. So we went into quite some detail on these guys. So as far as your summary page, this is your second worksheet. We'll go through it pretty much together. The first question said, in which sequence are the rock layers listed in order from oldest to youngest? Well, the first thing you should do is match up your matching layers, all right? Match them up. If this and this have the same fossil, then you know that they're the same, that these are the same, right? So that means E is right in between here. And if you saw, I'll take away the ink for a second. That squiggly line represents an unconformity. So what layer do you think was removed? E. All right, so if we did continue and overlay them, it would look like this. All right, and this is basically C and F. Here's E, here's B and D, which were the same, and then you had A. Okay, so for your answer for 1, in which sequence are rock layers listed in order from oldest to youngest, you should have had choice 4. All right, that's number 1. And then number 2 said, based on the given rock and fossil, which 2 letters most likely indicate parts of the same layer? So for number 2, you should have chosen choice 2. All right, which was saying B and D are the same, which we know from right here. Okay, next. Yeah, over here. Let's get rid of that ink. This one is saying, here's your cross-section, blah, blah. Which letter is the best index fossil? So according to this, the best index fossil you should have chosen, again, widespread. It should be in all 3. And short-lived. It should only be in 1 layer. And if you chose C, that would be correct. Over here, this is moving on to the bottom one, saying, why is the volcanic ash layer a good time marker for correlating rocks? Volcanic ash, talking right here. Well, if it's a good time marker, that means that it's widespread and short-lived. All right? You see a trend, right? I must have said that 10 times already. All right, so here's a couple practice regions questions. For the first one, the drill core samples below were taken from 2 locations 1,000 kilometers apart. Rock layers 1 through 8 have been labeled. Some index fossils, oh, there you go, are shown in the layers. Which numbered layers most likely formed at the same time? So they mentioned index fossils, and they're asking which ones existed at the same time. Now, you don't have any repeat fossils, right? There's 4 different fossils, so you need to look them up in page 8 and 9, right? And if you do that, you should notice this. So your choice should be any of them that match up Ordovician. So that's 3 and 5, right? They both existed in the Ordovician. Next one, identify the rock unit that is the youngest and explain why. Youngest meaning it came last, and you should pick A. And A is the youngest because it's on top, and notice there is no contact metamorphism here. B is not burning A. So that means B was an extrusion. It came out, it burned through D and C, then it cooled, and then A was deposited on top. All right, so there is your day 8 correlation lesson. There really isn't any work for you to do after that. Just make sure that your castle learning is done and make sure that your lab is done. All right, stay well, be safe, and hope to see you guys soon. Miss ya.